Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 167. Please turn to it. Page number 167, and today is our lesson number 5. Question number 14 and 15 are the ones that we're going to do first, and those two questions pertain to the table that is given to us on the top of that page, a table that I have reproduced here. The very first question, question number 14, is asking us for, question number 14 asks us for the average enrollment for Algebra 1. Average enrollment for Algebra 1. There are three sections in Algebra 1, A, B, and C, as we can clearly see here, and these are the enrollment. 24, 25, and 29 are the enrollment in section A, section B, and section C. And 24, 25, and 29 are the three enrollment. The fact that they are being held in period 2, 3, and 4 is of no interest to us at this point. They are asking us nothing at all about what period they are being held in. We just want to find the average enrollment. So let's find out, shall we? Let's add them up. So we see 20, 20, and 20. Let's not worry about these 20s right now. Let's keep them in advance. So what we have here is 4. 4 plus 5 is 9, and 9 plus 9 is 18. So we have 18, and we have three sections. 18 divided by 3 is 6, and then every one of them had 20 more. So the average is 26. The average is 26. Let's move on to the next one. Number 15. Number 15. If someone asks us, for example, to find the average of 33, 32, and 34, we don't have to waste our time adding up all the 30s. These 30s are just 30s. Just add up these three numbers. 3 plus 2 is 5. 5 plus 4 is 9. So the sum of these three numbers is 9. And there are three of them. There are three numbers. And there is 30 for every one of them. So the average is 33. That's all. Do you understand? You don't have to waste your time adding up 33, 32. There's no need for it. Do you understand? Not only you'll end up with a large number here, but then you're going to have to divide that large number by 3. Why do extra work? Why carry that extra luggage of 30s from everybody? Do you understand? Leave it alone. Number 15. In number 15 we are told the school owns 2 classroom sets of 30 calculators each. Alright, so we have 2 sets of calculators. Number of calculators we are told is 30 plus a 30, and then they go on to tell us that there are 2 calculators from set 1 and 6 from the other set that are not available for use for the students because they are being repaired. So two calculators from one set of 30 and 6 from the other set of calculators are busted. They're broken. They do not work. They are, as we say, malfunctioning. 2 and 6. I do not know why, but it sounds very sophisticated when they malfunction as opposed to busted. Do you understand? So that's 28 plus 24. What is the question asking? For which of the following class period, if any, are there not enough calculators available for each student to use a school-owned calculator without having to share? So no student is going to share. We simply have to find out if there is any period at all. There might not be any. If there is any period at all in the school time period where they may not have enough calculators on hand to give it to each of the students taking the math course at a given time. Let's find out. Shall we? Enough of the talk. So now we have to look at period by period. So let's start again. Let's start here by period 1. Then we have period 2, period 3, period 4, 5, and 6. Period 2, period 3, period 4, period 5, and period 6. That one should not be a Roman numeral because I switched to Arabic numeral. There we go. Period 1. How many period 1s do we see? Let's erase this part. We no longer need this part here. Let's erase it. Let's concentrate on period 1. How many period 1 do you see? Well, I see only one period 1. This is period 1 right here, and it's 21. Period 1 is 21. We have plenty of calculators. We have a set of 28 here and 24 here. That's perfectly fine. How many periods 2? Period 2, I see one period 2 here, which is 22. This is period 2. And then any other period 2? Right here are 22, period 2, which is 24. This is period 2. So we have 22 and a 24, a 22 plus a 24, which is also fine, because this 24 is perfect for this set here, and then here 22, we have plenty into 28 here to cover those 22. That's it. Don't waste your time adding up numbers, okay? Just compare them. So that's it. The period 2 is also fine. Period 1 was fine, period 2 is fine. Let's look at period 3. I'm going to erase all the periods that we already took care of so it doesn't get too crowded. We're done with period 1 and period 2. That's all done. It's all gone. Period 2 is gone. Let's look at period 3. This was 25, and here's your period 3, 25. Any other period 3? Right here is another period 3 of 23. So we have 23 and a 25, which is also fine, because this 25 that we see here is covered by this 28, and this 23 is covered by that 24. So we are fine. Period 3 is also fine. Let's move on then. Period 4. Any period 4. Let's erase period 3. We're done with it. Period 4 I see here are 29 and a 28. This might be a problem. We have a 29 and a 28. A 29 and a 28. This 28 that we see is fine with this 28. That 28 will take care of this 28. But we have 29 here. But in the second set we only have 24. You see? We need 29 calculators and a 28 calculator. We need 29 calculators for this Algebra 1 period C, and we need Algebra 1 section C in period 4, that it is being held in period 4, and we need 28 calculators for Algebra 2, which is also being held in the same period 4. They are being held at the same time. This 28 will cover this 28 calculators will be enough for these 28 students, but then we have 29 students here, but only 24 calculators in the second set. That won't do it. Period 4 is one of the answer choices. Period 4 is where we do not have enough calculators. Let's find 5 and 6 very quickly. Period 5, well, there is no period 5. What the hell? There is no period 5 here. So that's not even applicable. That's not applicable. And period 6 is very simple. In period 6 we only have 19 students. We have only 19 students. We have plenty of calculators, 28 and 24. So the answer is period 4. Let's move on then. Question number 16. Question number 16. In question 16 we are told that the sum of each row, each column, and each diagonal is equivalent. Their sums are equivalent, they are equal sum. And here's what is given to us: x, 8x, and negative 3x, negative 2x, and a blank space, and a 6x, and a 7x, a negative 4x, and a 3x. This is too much fuss about nothing at all. It's a very straightforward problem. All we have to do is just pick one row, one column, and see what they add up to. We can't add up a diagonal because diagonal one is missing here. So if you add up, for example, first row here, we get 1x plus 8x is 9x, 9x minus 3x is 6x, which is exactly what we find if we were to add up this column. Negative 3x and a positive 3x, they will cancel each other out, and it's 6x, you see? Which means the sum of any rows or any column or any diagonal has to be 6x. So here we have negative 2x, here we have 6x already here. If you look at row number 2, we have 6x already, which is supposed to be the total sum. And we have a negative 2x, we need to get rid of this negative 2x. How do we get rid of that negative 2x? By adding 2x to it. There we go. Now this positive 2x and a negative 2x are going to cancel each other out. They're going to cancel each other out, and we end up with a sum of the 6x. Again, if you take any diagonal, 2x plus x is 3x, 3x plus 3x is 6x. Again, you see, Negative 3x and a positive 2x is going to give us negative x. Negative x and a positive 7x is going to give us 6x. No matter which way we look, each row, each column, each diagonal now will add up to 6x. That's all. Let's move on to the next page, number 17. Number 17 on the next page, page number 168. Let's do it here. In number 17, we are told that we have a point A, which is to be graphed in the Cartesian coordinate system. And question simply is, this point A that we have there, in which quadrant will it have opposite signs, I believe that. Let's see how they word it. Point A is to be graphed in the quadrant not on the x-axis of the standard xy coordinate plane. If the x coordinate and the y coordinate of the point A are to have opposite sign, then point A must be located where? They are to have opposite sign. In other words, if x coordinate of point A is positive, then the y coordinate has to be negative, and vice versa. Well, it's quite straightforward. In this quadrant, they are both positive. X is positive, and so is y. This is our first quadrant, so that's not it. In the second quadrant, x is negative, and y is positive. As we go up, y is positive, x is negative. So that would work. That works. Second quadrant works. In the third quadrant, we have x which is negative, and so is y. As we go down, y is negative as well. So that does not work. The third quadrant does not work. And in the fourth quadrant, we have x that is positive, x coordinate is positive, and y coordinate is negative. So it turns out that the answer is fourth quadrant and the second quadrant. In both second quadrant and fourth quadrant, we have situations where the x coordinate and the y coordinate are of the opposite sign. That's all. Very simple. You understand? Let's go on then. Number 18. Number 18. Before we go to number 18, it says something minor, something very very trivial, depending on your point of view, or something very grave, something serious, depending on your point of view, as I said. But sometimes, not always of course, but sometimes I've heard students mispronounce this word. And I want to make sure that you pronounce it properly, so I'm going to actually put down the pronunciation for you here for whatever it's worth. It is to be pronounced, this word right here is to be pronounced, let's put it here. Where can we put it? Car. Cartesian coordinate. Do you understand? Cartesian coordinates. I've seen people pronounce it in many different ways. It's not anything else. It's Cartesian coordinate. It's not Cartesian. Do you understand? Many times I hear students mispronounce it. Cartesian coordinate. It was invented by some mathematicians in the 16th century, I believe. René Descartes, I believe was his name. But anyway, it's Cartesian coordinate. Number 18. Some French dude from what I understand. René. In number 18, we have a person who is proud to have 4 sweaters. He happens to be a proud owner of 4 sweaters, 6 shirts, and 3 slacks. 3 slacks. I believe that's how we pronounce it. 3 pantaloons. Do you understand? And the question simply is, how many different outfits will he be able to put together, having one item from each of these 3 categories? Do you understand? Let's find out, shall we? It's very simple, very straightforward. He wants to have in his quote-unquote outfit. He wants to have a sweater. He wants to wear a sweater. He wants to have a shirt. And because it's a special occasion, he prefers to have also the pants, the slacks, the pantaloons. Do you understand? So, how many different ways can he choose a sweater? Well, he's got 4 of them. Well, if it's got 4 sweaters, he has 4 choices. There are 4 ways he can pick a sweater. After having chosen a sweater, how many different ways can he pick a shirt? How many different ways can he pick a shirt? Well, there are 6 ways. And similarly, there are 3 ways for him to choose slacks. And therefore, the total number of choices that he has is the product of these three numbers, which is 4 times 6, which is 24. 24 times 3. And how much is 24 times 3? How do I know? I know 25 times 3. That I do know. 25 times 3 is 75. And therefore 24 times 3 should be 3 less than 75, which is 72. 72. Do you understand? But we have to multiply the numbers, not add them. We have to multiply them. Do you understand? Let's go on then. Number 19. Number 19. Now I don't want you to memorize. I don't want you to go around I don't want you to go around memorizing that you have to multiply them. Just understand the concept behind it. Why we have to multiply them and not add them. For example, if I have one shirt and two pants, let's call the shirt S and the pants A and B. Or how many outfits can I have here? As you can see, I have my shirt and I have my pants. How many different ways can I pick a shirt? Well, there's only one way I can pick a shirt because I only own one shirt. How many different ways can I pick a pants? There are two pants I have, so there are two choices I have for pants. The question is, do I multiply the two numbers? Or do I add the two numbers? Or do I multiply the two numbers? Well, if I add the two numbers, what you're saying is that I have three different outfits, which you can clearly see I do not. There are only two outfits I have, which is either wear my shirt with the pant A or wear my shirt with the pant B. That's all. There are only two outfits I have because I have two pants and one shirt. So once I put my only shirt, I have two choices. I could put either put pant A on or pants 2 on. That's all. So we do not add the two numbers because that would have given us the answer of 3. We multiply the numbers. That's how you remember it. Keep it simple. Do you understand? Make up a simple scenario and ask yourself what would apply there. Number 19. In number 19 we have 100,000 tons of sand which is required to produce 60,000 barrels of terry. The question is, that's the proportion. The question is, how much sand do we need? How much sand do we need to produce 3,000 barrels? 3,000 barrels of terry. Well, let's find out, shall we? Let's do it here. Set it up as a proportion, as I said. So we have terry and we have sand. We have terry and we have sand. We are told in the beginning that we need 60,000 terry is produced. 60,000 is produced from 100,000 tons of sand. Now forget about this thousand. The three zeros that you see, just forget them everywhere. Okay, just remember, just know that we are doing it in thousands. And the question is, how much sand will we need? How much sand will we need? That's the unknown quantity. If we have only 3 tons of, if we only require 3 tons of terry, we can actually do our entire process if you like. You can do the entire process, cross multiply and solve for x. Or if you're quick enough, you can immediately see that 3 happens to be the 20th of 60. 60 divided by 3. 60 divided by 3. 60 divided by 20. 60 divided by 20 will give us 3. 3 is the 20th of 60. So now you simply have to ask yourself, what is the 20th of 100? A tenth of 100 is 10. 20th of 100 is 5. But if you don't want to make it this complicated, let's do it out. Cross multiply. If we cross multiply, we find that 100 times 3. 100 times 3 equals 60 times x. Divide both sides by 60. 60 is going to drop out, and our x is equal to whatever we find here. If you divide top and bottom by 10, so we can knock out the 0. Divide top and bottom by 3, so this 3 goes away and 6 is going to become 2. And now we are left with 10 divided by 2, divide top and bottom by 2, and 10 will become 5. You see, we said that before, that 1/20th of 100, 1/20th of 100 is 5, which is what we find here. Why is it 5? Why do we 5 here? Why do we need 5 here? Because 5 happens to be 1/20th of 100, which makes sense because 3 is exactly 1/20th of 60. That's all. Listen, number 20 is the last problem on that page there. I will not do it today, we'll do it in the next video because that happens to be a very special question. I want to spend some time on it. It deals with, well, when we get to it, you will see it. We'll do that separately together, okay? Separately tomorrow, okay? Bye now.